Right now, at this very second, millions of people are having deeply personal, intense conversations with an entity that just doesn't actually exist. We instinctively type out please and thank you into the text box, right? We completely confide in it when we're feeling overwhelmed by a huge project at work, or we actively ask it for incredibly intimate advice on our careers, our families, and our relationships. We interact with it every single day as if there is a thinking, breathing, feeling intelligence sitting just on the other side of that glowing screen. We literally treat it like a mind, like a friend, like a tireless, omniscient coworker. But the truth, the absolute reality of the situation, it is just a mirror. The illusion of consciousness is incredibly powerful, and it's been meticulously engineered to feel completely natural to us. But that illusion entirely shatters the very moment you see what is actually running under the hood. ChatGPT, Gemini, and Claude have never had a single thought.
In fact, the model that just answered your email has never seen a single email. Let that sink in for a second. It has absolutely zero memory of a glowing inbox. It has no conceptual framework of what a sender or recipient actually is, and it has absolutely no understanding of what the words you just typed actually mean to your life. It is entirely, 100% blind to the human experience. Welcome to the overview effect, where you zoom out and everything changes.
Okay, let's dive into this. To truly grasp what is actually happening when you type a prompt into ChatGPT, Gemini, or Claude, we have to look way, way past that familiar, friendly little chat window. That clean, minimalist interface, you know the one. Just a simple white text box and a gently blinking cursor is honestly a masterpiece of psychological misdirection. It genuinely feels like a conversational partner because it was expertly, deliberately designed to feel exactly that way. But behind that sterile, unassuming white box lies a staggeringly complex, downright dizzying mathematical backend. We all casually throw around the phrase artificial intelligence to describe almost everything today, from thermostats to search engines. But to truly understand what you are interacting with, we really need to carefully sort out the terminology first.
To take apart this engine, we first have to navigate what I like to call the nested dolls of artificial intelligence. Think of artificial intelligence as this massive, overarching umbrella term covering literally any system that mimics human intelligence. That goes from a simple chess-playing program from the 90s all the way to a modern self-driving car. Inside that broad category is a smaller doll, machine learning. This is where algorithms aren't explicitly programmed by a human line by line, but instead they learn the rules automatically by studying vast amounts of data. And inside that, we find deep learning, which uses insanely complex neural networks made up of many, many layers of artificial neurons. Finally, we get to large language models, the highly specific engines actually powering our modern chatbots. These are just a very specific subset of deep learning, living within the broader category of generative AI. Replacing the idea of some magic black box with this structured, logical hierarchy is absolutely the very first step to dismantling the illusion.
So what exactly is a large language model, or an LLM for short? If we strip away all the tech magic, the slick marketing, and the endless hype, an LLM is simply a system trained to predict the next word in a sequence. That's it. It just does it again and again incredibly fast until it can hold a conversation. That is the core mechanism of the entire illusion. This whole multi-billion-dollar infrastructure is built to do one incredibly simple, sequential task: guessing the next word. Human language is inherently sequential, right? If I say the phrase peanut butter and, your brain automatically cues up the word jelly. The machine is doing exactly that, purely mathematically. But it does this at a massive, almost incomprehensible scale. It isn't just guessing the next word of a simple sandwich order, it is predicting the next word of quantum physics equations, airtight legal contracts, and complex medieval poetry, all based entirely on pure mathematical probability.
It does not think about the future. It only guesses the next footstep. When it starts generating a response, it has no grand master plan for the end of the paragraph. It doesn't hold a belief, it doesn't have a bias, and it certainly doesn't have an opinion about what it is currently saying to you. It simply places one mathematical foot in front of the other, blindly predicting the most likely next step in the sequence over and over and over again.
But to really understand how it actually takes that footstep, we need to understand what the model actually sees. Because a model doesn't look at language the way you and I do. It doesn't see whole words, and it definitely doesn't see individual letters. It sees what we call tokens. A token is basically a piece of a word, usually about 3 or 4 letters long. These are the actual units the model sees. Take the word strawberry, for example. When that enters its digital brain, it comes in as 2 totally distinct pieces, straw and berry. From the model's perspective, there are no individual letters in there at all. just two solid, unchangeable numerical shapes. This is exactly why the smartest writing assistant ever built by humanity sometimes totally struggles to reliably tell you how many R's are in a word, because it processes these rigid numerical tokens rather than fluid letters. Asking it to count the R's in strawberry is basically like asking a human to taste the color blue. It's simply the wrong sensory input entirely.
So the absolutely crucial point here is how the machine actually knows which token is supposed to come next. It uses an incredibly elegant piece of architecture called a transformer. Now, a transformer is simply a way of letting the machine mathematically weigh which earlier words matter most when it's guessing the next one. Think of it kind of like reading a really complex, twisty detective novel. Before this specific architecture was introduced, older AI models would often completely forget about the murder weapon introduced in Chapter 1 by the time they finally reached Chapter 3. They simply couldn't remember the past. But the transformer uses what is called an attention mechanism. This breakthrough architecture allows the machine to basically hold the entire book in its head all at once. It instantly connects a subtle, tiny clue on page 10 to a major motive on page 300. It selectively pays attention to the entire context of your prompt so it knows exactly what token it needs to generate next.
But here's the catch. A brilliant architecture like the transformer is completely useless without immense, mind-bending scale. Let's shift our perspective for a second to the sheer size of this operation. Think about a human lifetime of reading. Over an entire lifetime of avid, everyday reading, you might consume tens of thousands, maybe even hundreds of thousands of words. Now look at an LLM. These models ingest trillions of words from the public internet. Trillions! They read billions of forum posts, millions of digitized books, literally all of Wikipedia, and decades of dense research articles. They consume a towering, incomprehensible digital mountain of data. We're talking about more text than a single human could possibly read in 1,000 lifetimes. When we say large language model, that word large refers directly to this staggering, unprecedented volume of ingested data.
To put that staggering scale into perspective, let's look at a specific number: 300 billion. GPT-3, which was the model that served as the foundation for the very first widely used version of ChatGPT, was pre-trained on exactly 300 billion tokens. And honestly, that was just the beginning. The newer models we use today consume vastly more data than that. By literally eating the entire internet, they build an incredibly dense, highly complex statistical map of human language. It is essentially the linguistic equivalent of meticulously mapping every single star, planet, and asteroid in an entire galaxy just to understand the overall shape of the universe.
Now, the second reason we call these models large comes down to something called parameters. A parameter is essentially one of the model's adjustable knobs. Modern models have tens or even hundreds of billions of them. When the machine tries to predict the next word, it turns these billions of dials to optimize its guesses. Let's go back to our sandwich. If the prompt is peanut butter and the machine randomly guesses apple, the system mathematically punishes those specific knobs so it won't ever make that silly mistake again. But if it correctly guesses jelly, it rewards and strengthens those specific connections. It does this optimization process over and over and over again across trillions of tokens, slowly and methodically dialing in the absolutely perfect settings. And this relentless, massive-scale optimization creates a truly staggering side effect. When you force a neural network to perfectly predict the next word across literally every single topic humans have ever written about, a simple parlor trick morphs into something profound. Think about it. How does a machine that only predicts text suddenly write perfectly functioning Python code? Well, because to predict the perfect sequence of code, it implicitly has to learn the actual logic of programming. It has to effectively learn physics to accurately predict the end of a dense physics paper. The machine stops just predicting text, it begins to infer the hidden underlying rules of reality itself.
But raw predictive power is entirely useless to us if the system doesn't know how to actually interact with you. Building a functional mind requires crossing a bridge between that chaotic web of data and the polite, helpful chat window you use every single day. This transformation happens in two distinct stages: pre-training and fine-tuning. The transition from building a raw, chaotic brain to a structured, helpful tool is the true secret behind modern AI.
Stage 1 is pre-training. This is where the model does its massive next word prediction on the raw, completely unlabeled text of the internet. It learns grammar, it learns facts, reasoning, and the vast, messy spread of human knowledge. The result of this stage is called a foundation model. But a foundation model really isn't very helpful by itself. It just wants to blindly complete sentences. If you ask a raw foundation model a simple question, it might just reply with 3 more questions, or worse, spew toxic internet slang, because it's simply mimicking the chaotic, unfiltered web it read. It needs to be tamed. So we bring in stage 2, fine-tuning. This is where we teach it polite, curated behavior.
As the process shifts to fine-tuning, we completely stop feeding it the chaotic internet. We stop the noise. Instead, we feed it carefully curated examples of actual humans answering questions politely and helpfully. This represents a massive, fundamental paradigm shift in computer science. Nobody programs an AI directly anymore. If you want it to summarize a business meeting, we don't sit down and code the strict logical rules of summarization. We just show it 10,000 perfect examples of a great meeting summary, until those hundreds of billions of knobs magically align with our exact expectations. We tame the machine purely by showing it exactly how a helpful assistant should behave.
So, where does that leave us? We have just completely dismantled the mechanical reality of this entire system. It doesn't have a soul, it doesn't think, it simply predicts mathematical tokens using billions of parameters, optimized over trillions of words. It is an illusion, a highly advanced mirror reflecting our own language right back at us. But when you ask it to solve a highly complex medical problem or write a beautiful, moving piece of music, and it actually does it flawlessly, it forces us to step back and ask a massive philosophical question. What does it actually mean to understand something? And does it even matter if it understands, if the output is exactly the same either way?
When you stop treating artificial intelligence like it's some incomprehensible magic spell, you finally gain the actual power to wield it. Welcome to the overview effect, where you zoom out and everything changes. If this changed how you see things, subscribe to the overview effect. New perspective every week.